Topic linear higher order differential equation with constant coefficient. Another new topic: linear higher order differential equation with constant coefficient. A differential equation which is a form of dn y upon dxn a1 dn minus 1y upon dxn minus 1 a2 dn minus 2y upon dx n minus 2 a and into y equal to x, where a1 a2 a3 up to an are constant and x, that is a function of x, or a constant or a zero. Linear higher order differential equation with constant coefficient. What is the order of this equation? What is the order of this equation? Order?
बताओ.
क्या order?
N, sir.
N. That is a higher?
Yes, sir.
Greater than 1, that is called a higher order.
Yes, sir.
Degree?
Degree भी 1, sir.
1.
Yes.
Degree 1, so that is a linear.
Yes, sir.
And derivative involves, so that is a differential equation.
Yes, sir.
Higher order, degree 1, so that is a linear. That means linear higher order differential equation with constant coefficient. The coefficient, that is a1, a2, a3, an are all
Constant.
constant. For example, let us consider dq y upon dx cube plus 3d square y upon dx square plus 3d by dx and plus y equal to 0. The order of this differential equation, that is 3. That is a higher order.
Yes, sir.
And degree is
1.
1. So that is a linear.
Yes.
And the coefficient of this constant 1, 3, 3 into 1. So the all coefficients are constant. So combined, we can write this linear higher order differential equation with constant coefficient. Clear?
Yes, sir.
Now you have to notice that capital D means d upon dx. D square means d square upon dx square. dq means dq upon dx cube. And dn means dn upon dx. Or dy means dy by dx. d square y means d square y upon dx square. dqy means dqy upon dx cube, and up to so on. dny equal to dny upon dx. So first we that differential equation, linear higher order differential equation with constant coefficient, first we convert in capital D.
Capital D.
For example, Here we can write this dq y, that is 3d square y plus 3 dy plus y equal to 0. Also that equation we can write this dny a1 dn minus 1y a2 dn minus 2y and up to so on an into y equal to क्या?
X.
Now taking common y, so we can write this dn a1 dn minus 1
a2 dn minus 2 plus
and up to so on
an dn 1.
into y equal to x. Also here also we can write this dq plus 3d square plus 3d plus 1 into y equal to 0. Here we can say that x must be function of x or a constant or a
Zero.
In this equation, for example, x, we take x equal to 0.
Yes, sir.
So first we, any equation, linear higher order differential equation with constant coefficient, first we convert in capital D. And that function is fd. That is a function of fd. That is a function of fd into y equal to 0. We are fd equal to dq plus 3d square plus 3d plus
1.
1. That is a function of fd. We can write this fd into y equal to 0. So also here we can write this fd into y equal to x. So first we any equations convert in capital D. Second step, then find auxiliary equation AE. Auxiliary equation short form AE. Always we can write this only AE. To find the auxiliary equation, first step, second convert in capital D, and third that is a auxiliary equation. To find the auxiliary equation, for which, what is the auxiliary equation? So now here we put D equal to N in FD and equating to 0 and equating to 0.
Oh, yes.
That means Fm equal to 0 is called a AE, auxiliary equation. To find the auxiliary equation simply, in FD put D equal to M and equating to 0. D की जगह M put up करिए और 0 के बराबर करिए. So that means here find the auxiliary equation AE. Now here FD equal to dq plus 3d square plus 3d plus 1. So now here we put d equal to n
Yes.
and equating to 0. We can write this auxiliary equation, that is
f of m
Fm equal to 0. That means mu
3da squared
plus
3m plus 1.
plus 1 equal to. So here we get the equation, auxiliary equation, that is Fm equal to 0. So solve for n. Solve for n. Say that is a m1, m2, m3 and up to
mn
solve for m. Suppose that value of m, that is m1, m2, m3. Here we get also the negative values, that means plus minus anything, any one. Plus minus m1, m2 and m3. So here we solve this equation in n plus 3m square plus 3m plus 1. We can write that 1 cube. 1 cube. That is a formula of a cube plus b cube plus 3ab square plus 3a square b plus b cube. We can write this n plus 1 का whole cube equal to 0. Here we find all possible values of m. We can write this m1, m plus 1, m plus 1 3 times equal to 0. So that is m equal to minus 1, minus 1.
Minus 1.
So that are the three steps to find the solution of linear higher order differential equation with constant coefficient. First we convert in capital D, then we find the auxiliary equation, for which solve it for n, find the value of n. Then here we noted that as d into y equal to x, complete solution. Complete solution of 1, that is y equal to CR plus PI. Complete solution, that is y equal to CR plus PI. Full form of CR, that is complementary function. Complementary function. And full form of PI, that is a particular integral. It is defined as, that is PI equal to 1 upon FD into X. That is a general formula for PI. General formula for PI. General formula for PI, that is PI equal to 1 upon FD into X. Now here FD equal to here d की power n, a1 d की power n minus 1 and up to so on n. But here FD equal to, that is d cube plus 3d square plus 3d plus 1. So pi equal to 1 upon fd into
X.
Now here we say that x, that is a function of x or a constant or a 0. Suppose x equal to 0. Suppose x equal to 0. X equal to 0. So from 2. So pi equal to, from this, pi equal to 1 upon fd into 0 equal to 0.
Yes.
So particular integral must be 0. If x equal to 0 in numerical, x equal to 0, so therefore pi equal to 0 by definition of general formula for pi. Pi equal to 0, so from 2, complete solution, that is y equal to only